Welcome to my book review on the book Storm in a Teacup, The Physics of Everyday Life by Helen Czerski. And just finished reading it. It's basically a pretty good little book. Before I get into looking at the book itself, I want to talk about the author, Helen Czerski. I've been reading a little bit about her, and she's got a PhD in physics from Cambridge. And she's worked with the Scripps Institute. After she got her PhD, she went into studying the ocean and the physics of bubbles, and that took her to California, to Rhode Island, and a bunch of other places. So she's been around quite a bit, and she's really good at converting everyday physics, the objects that we see in the world, into an understanding of what's actually going on. So that is her strength, and she's done a bunch of stuff with the BBC and written some other books. So she's very good at what she does, converting what we see in the real world to understanding of physics. Let me just kind of go through the book a little bit and talk about some of the features. I got a couple of excerpts I want to read about. So that's the book cover. Let's go over the table of contents real quick. So it talks about, it opens up with popcorn, how popcorn works, and that's kind of neat, the way the steam explodes. And just talks about a bunch of different topics. Small is beautiful, a moment in time, making waves, talking about wave mechanics. And then why don't ducks' feet get cold? And that's kind of interesting about the way the blood moves around. Spoons, spirals, and Sputnik. When opposites attract, it's got to do with electromagnetics. And a sense of perspective has to do with scale. And so then it's got some references in the back. So it's a pretty standard as far as that goes. But I did enjoy reading it just because it gives me a different perspective on physics. I'm so used to reading the standard physics-related textbooks written by pure academics that this was kind of a little refreshing to give me a little different perspective on things. I'll read a little excerpt, just a random bit here. In 1876, Maria Spetterinia became the only woman ever to cross Niagara Falls on a tightrope. There's a photograph on her halfway across, serenely balanced and with peach baskets attached to her feet to increase the drama. But the most obvious prop in the photo is the long horizontal pole she's carrying, the best aid to balance. Arms will only reach out so far, but this arm substitute was a large part of the reason for Maria's exquisite control. Her T-shape meant that if she started to lose her balance, it would only happen very slowly because the ends of the poles meant that the same torque has much less effect. So this is kind of demonstrating when she's walking across those wires, the big wire here, and here's this big pole that she had. It's very long. Here she is, young lady there. This was essentially like holding on to something almost for her, because it took a lot of torque to move that, so she could kind of use this almost as a stationary point to gain her own balance. So it was kind of neat. She explained the physics of how that works and angular momentum and torque. Then she goes down to talk about how that conveys to a T-Rex, that they were so big and they couldn't change position or move their head rapidly in response to a new threat because they were so large and had such a big angular momentum was required to move them. So she's kind of taken the interesting old phenomenon or interesting demonstration and kind of explaining the physics behind it. That's her strong suit. Just another little one, random excerpt here. Generally, this is in Why Ducks Get Cold Feet. Why don't ducks get cold feet? And I should have found that segment. That was pretty good too. Generally, the solid expansions expand less than liquids as they're heated up. The expansion is only a tiny fraction of the overall volume, but it's enough to make a difference. Next time you cross a bridge on a foot, keep an eye open for the metal strips at either end of the bridge running across the road. It's likely to be made out of two interlocking cone-shaped plates. These are expansion joints, and once you know what you're looking for, they're pretty common. And you do see these a lot on bridges, especially if you're out driving. They're kind of metal, because the expansion of the concrete occurs at different rates, and they have to take that into account. And like on sidewalks, you'll see the little black strips of tar in between there. Those are expansion joints also. So that's just common physics that you see every day, and she's kind of tied it into letting you understand it. One thing in this book you will not find is really equations. I didn't see any graphs either, or charts. I kind of like graphs and charts, so but that's okay. She did a good job explaining things, and she's got some references in the back here if you want to look up more things, help you understand if you really get into it. So overall, a really good book. Definitely a good read if you want to learn a little more about basic physics and how the world works. This is worth your time. I enjoyed it.